Okay, number 1, we'll just use power rule. We bring down the power, then power minus 1. Okay, number 2, this is actually d dx of x to the 1 over 3. Okay, so same thing, we bring down the power, then power minus 1. Right? Then this one, same thing, we'll bring down the power, square root 2 x, then the power will be negative square root 2 minus 1. Then number 4, okay, so if we have a fraction like this and your x is at the bottom, what you have to do is, number 1, you change the sign, so it's a negative, then you write the power here, the original power here on top, divided by x, then this number you add with a 1, right? Then this one, power bring down, then power minus 1, which will be negative 4 over 3 x, then this is negative 7 over 3. Okay, then this will be a d dx of square root is actually to the power half. So let's group all the power together. So it's a half 2 plus pi, right? Then you can bring down the power. Okay, it's a half 2 plus pi x. This one plus 1. Okay, half of 2 is 1. Then 1 minus 1 is 0. So you have pi over 2, right? Number 7. Okay, actually I prepared like around 100 questions, but I'm not sure if we can finish it. I think it would be good if we can do like at least 50, right? Then number 7, we have d dx of absolute value of x. Okay, so recall the definition of absolute value of x. It is equals to x when x is greater than 0. It is equals to 0 when x is 0, and is negative x when x is smaller than 0. So we have to split it into 2 parts. Actually, it's 3 parts, but never mind. Okay, so when x is greater than 0, then d dx of it will be equals to 1. If x is smaller than 0, then d dx of it will be negative 1, right? Then what about 0? Okay, if you draw the graph, you'll notice that it is actually a sharp corner at x equals to 0, which means it is not differentiable at this point. So therefore, we said that d dx when x equals to 0 of absolute value of x is equals to undefined, right? So it will be like this, okay? It is equals to 1 when x greater than 0, undefined when x equals 0, then it is negative 1 when x smaller than 0, okay? Okay, by the way, this question I arranged in from easy to hard, then we will have triangle, exponential, logarithmic, hyperbolic, and inverse triangle at the end of this question bank. Okay, but I doubt if we can reach that. Anyway, let's continue. We still have like 56 minutes. Okay, number 8, d dx of 4x squared. Okay, this is actually a constant multiple, right? So it is equals to, you can take out this constant. Okay, so it's a 4 d dx of x squared. Then you can use the power rule, bring down the power, so it's a 4 times with a 2, x power minus 1 is 1, so it's add x. Number 9, okay, d dx negative x4 plus 3. Okay, so same thing, we will use the power rule. Okay, so it's a negative 4x power minus 1 is 3. And when you differentiate a constant, because the constant graph is something like this, right? And the gradient of it will be 0, so it's a plus 0, right? Number 10, d dx x squared plus 2x plus 8. Okay. By the way, if we have multiple terms, you can just use a sum and difference rule, and we have product rule and quotient rule like that. Okay. So then you bring down the power, 2x to the 1 plus 2. Right. Then number 11, d dx 5x cubed minus 3x squared. Okay, so for this, same thing, we'll bring down the power, and this is actually a constant multiple. You can just multiply both of them together. So it's a 15. 15x squared minus 3 times 2 is 6x to the first power, right? Then number 12. Okay, so this is actually a countdown video, and I will try to do as many questions as possible in 1 hour. Okay, So it's a 4x cubed over 3. Okay, so again, this is actually a constant multiple. You can just take it out. And 4 over 3 times 3 is 4. So it's a 4x power minus 1 is squared minus this is 1. Okay. Number 13. d dx of 3x negative 2 minus 1 over x. Okay, negative power means it is actually 1 over, right? But in this case, we can just directly bring down the power. Okay, so 3 times negative 2 is negative 6x, then power minus 1 is negative 3. Then again, if we have a fraction like this, first you change the sign, then you write the original power on top, then x, this number plus 1. Okay, then number 14. I think we are doing good. 6x squared minus 10x minus 5x negative 2. Okay, so same thing, we bring down the power, so it's a 12. It's a 12x, then minus, this should be a 10 minus, okay, minus become a plus. Okay, it's a plus. 5 times 2 is 10x, then negative 3. This is actually the same concept here, you know. Do you see that? It's actually the same concept. You just change the sign because you multiply the negative power. That's why you need to change the sign. Then this number increase by 1 because when you minus 1 from negative number, the magnitude of it will become 1 greater than the original power. Okay, then number 15. d dx of, we have a shit ton of fraction here, minus 5 over 2x. Okay, so same thing. Okay, first this is a constant multiple, then you just change the sign, negative. Okay, then the original power on top over 3x power plus 1. Okay, simple, right? Then this one, power, you change the sign, then 5 times with the original power over 2x squared. So this is actually just 5, right? Okay, then number 16. Number 16. We have d dx of x cubed plus 4 over 3 x squared minus 5x plus 1. Okay, so we'll bring down the power, 3x squared plus 4 over 3 times 2 is 4 times 2 is 8 over 3x, then power minus 1 minus 5, then plus with a, you differentiate a constant, you get 0. Okay, so that's the answer. Number 17. Okay, d dx, we have x minus 1 x squared minus 2x over x4. Okay, this is actually a quotient, right? But for this question, I think we don't use quotient rule. We try to expand the terms, then we can simplify with this, which will make our life easier. Okay, so we are expand this. Okay, but you still need to write d dx. Then this should be over x4. On top we have x cubed minus 2x squared minus x squared plus 2x. Then you rearrange it. You have x cubed minus 3x squared plus 2x over x4. Then you can just play your indices. So this should be 1 over x. Sorry. So you have a d dx of 1 over x minus 3 over x squared plus 2 over x cubed. Okay, so yeah, you see, it's all the fraction. Change the sign, original power, power plus 1. Change the sign. 3 times 2 is 6 over x cubed plus, minus, minus 2 times 3 is 6. Is 6 over x to the 4th. Okay, so this number 17. Okay, we still have 50 minutes. Number 18. The question are getting harder and harder. Okay, d dx of 3x squared, 4x squared minus 1. And actually we have, for the first 50 questions, actually all algebra question. Then we'll start to have TRIG and all the transcendental function after question 50. Okay, for this one again, we are trying to expand without using the product rule, but actually you can use the product rule, and then it's up to you. So this should be I will try to expand it first. So it's a 12x to the 4th minus 3x squared. You bring down the power, 12 times 4 is 40, is 48. Okay, is 48 x cubed minus 3 times 2 is minus 6x to the first power. Number 19. if I make any mistake, please comment down below, yeah. 2x4, 6x squared minus 7. Okay, so again, I think we'll just expand it. Then we'll have other questions that we can use our product rule later. Okay, don't worry. Then this one you just expand it. So it's a d dx of 2 times 6 is 12 x to the 6 power minus 7 times 2 is 14 x to the 4 power. Okay, then you bring down the power. 12 times 6 is 72. Okay, it's a 72 x. Then this one power minus 1 minus 14 times 4 is 56 x to the 3rd power. Okay, then number 20. Yeah, this is where we can use the product rule. Okay, this is where we can use the product rule. Okay, number 20. Okay, d dx of 2x plus 1. Actually, but at first I want to do a 101 derivative challenge like Blackpenredpen, but yeah, at the end I decided to do the countdown. I think it's much fun at the end of the year, right? Okay, anyway, we'll use the product rule. I will show you one detail working and later we'll just directly do. Okay, so first we let u equals to the first bracket, then v equals to the second bracket. Okay, so du dx will be equals to 2, dv dx will be equals to 2x plus 4. Okay, then dy dx, if this is y, will be u. Okay, will be u. Then I will use red color for the derivative, 2x plus 4. Then plus with v x squared plus 4x minus 3 times with du dx. Okay, then we just have to expand the terms. This will be a 4x squared plus x plus 2x plus 4 plus 2x squared plus x minus 6. Okay, then we group all the like terms. 4 plus 2 is 6x squared. 2 plus 8 is, and we have another 8, so it's 18x. Then 4 minus 6 is negative 2. Okay, am I right? Okay, so this is for question number 20. Okay, 21, we still have product rule. Okay, number 21. Okay, we still have 47 minutes. I think we are doing very good. Okay, d dx of, where are we? 4x minus 5, 3x squared plus 8. Right? So again, we'll use the product rule, but this time I will do it directly. Okay? So it should be the first bracket. Okay, you copy the first bracket, differentiate the second bracket, you get a 6x, then plus 8 is 0. Plus, for product rule is a plus, you copy the second bracket, then you differentiate the first bracket. Okay, so this is 24x squared minus 30x plus 12x squared plus 8 times 4 is 32. Okay, then you group all the like terms. This one plus this one is a 36x squared minus 30x plus 32. Okay, then number 22, still a product rule. Okay, x minus 1. Do you have any New Year wishes? Since it's 2011 and 2020 is such a terrible year. Yeah, if you have any, then just comment down below. Anyway, we'll use the product rule again. You copy the first bracket, differentiate second bracket is a 2x minus 2. Okay, then plus if you copy the second bracket, then you differentiate the first bracket, is actually a 1. So this will be a 2x squared, then minus 2x, then minus 2x again, then plus 2, plus x squared minus 2x plus 5. Okay, then x squared plus x is a 3x squared, minus 2 is a minus 4 minus 6x, then this will be a plus 7. Okay. Then for me, I just hope I can get into a good university instead. I'm still a high school student now. Anyway, continue with question number 23. Okay, d dx. I'm now doing my year 12, and yeah, hopefully, luckily for my batch, actually the SAT is test optional for a lot of schools. So I'm quite fortunate, okay, due to the pandemic. Anyway, okay, again we'll use product rule. Okay, so this will be, you copy the first bracket, then you differentiate the second bracket, plus you copy the second bracket, you differentiate the first bracket, then just expand the terms. This should be a 3x to the 4th plus 3x squared, then plus with 2x to the 4th plus 6x, then you group all the like terms. 3 plus 2 is 5x4 plus 3x squared plus 6x. Okay, then the 4, d dx of x squared x cubed x plus 1. I just hope I can get into a good university so that I can continue to do my math. Okay, anyway, 3 times, sorry, you copy the first bracket, minus x squared. By the way, for all the product rule, you can actually, for all the questions here, you can actually expand the brackets, then you do just the power rule and sum and difference rule, okay? But yeah, I want to show you how to do a product rule, that's why I do it all by product rule. Anyway, then you differentiate this, should be 3x squared minus 1, then plus with, alright, second column, yeah, x cubed minus x plus 1 times, this should be a negative 2x, okay? Then extend the terms, this should be a 9x squared, then minus 3 minus 3x to the 4th minus plus x squared plus, this should be a negative 2x to the 4th power plus 2x squared minus 2x. Then you group all the like terms, arrange in descending order of the power. Negative 3 minus 2 is negative 5x to the 4th power. Then do we have any x cubed? No, okay. 9, 10, 11, 12 plus 12 x squared minus 2x minus 3. Okay. Then number 25. Oh, we are doing good. We still have 43 minutes. Okay. 25. Okay, d dx of x squared plus 1 x plus 5 plus 1 over x. Okay. So again, we use product rule. You copy the first bracket. Then you differentiate the second bracket. This should be a 1. This will be a 0. Then you change the sign, power, then square it. Then plus you copy the second bracket times with, you differentiate this, the first bracket. So it's a 2x. Okay. Then you just expand this. This should be a x squared minus, this and that can cancel, so it's a minus 1 plus 1 minus 1 over x squared, then plus 2x squared plus 10x plus 2. Right? They'll group all the like terms. 1, 2, 3. 3x squared, this and that can cancel, then plus 10x, then plus 2 minus 1 over x squared. Okay, so this is for our number 25. 26. Okay, d dx of x squared minus 1 over x cubed plus 1. Okay, so for this question we have no choice but to use the quotient rule. Yeah, because you can't split it like into 2 fractions, right? Okay, so I will show you one detail working, and later we will just like do it directly like the product rule here. Okay, so first we let u be the denominator, okay, which is x squared minus 1, and v equals to the numerator plus 1. Okay, then you differentiate both of them. Will be a 2x, then dv dx is a 3x squared. Clear this space here. Okay, so dy dx, or whatever you want to call it, will be equals to v du dx minus u dv dx over v squared. Make sure this is a negative here, yeah? Okay, what is our v? V is a x cubed plus 1 times du dx. Du dx is 2x. Then minus is a minus. U is x squared minus 1 times with a 3x squared. Okay? Then over v is x cubed plus 1, then you square it. Okay, so for quotient rule, usually we don't how to say, we don't expand the terms at the numerator, at the denominator. Yeah, at the denominator. Okay, unless you want to cancel out with some of the terms on numerator. Okay, so we just expand this, so it is 2x to the 4th power plus 2x, then minus 3x. What is this? Square is it? 3x to the 4th power, minus become a plus 3x squared over x cubed plus 1 squared. So for this question, we can see that we actually cannot cancel with any terms on top, right? So just leave it. Okay, 2 minus 3 is negative x4, negative 1 x4, then plus 3x squared plus 2x over x cubed plus 1 squared. Okay, this is number 26. Okay, 27. Okay, 27 is still quotient rule. We have a group of quotient rule here. Okay, 27 d dx of plus 5 over 3x minus 2. Okay, so we'll do it directly using this formula here. V du dx minus u dv dx over v squared. So first, okay, you know it is a quotient. Then we start from the v. V is the denominator. Okay. Then du dx is the the derivative of the numerator. So it's just a 2. Then minus is a minus, yeah. Minus, you copy the numerator, divide by the times with the derivative of the denominator. Then denominator square. Then you just expand the terms. This should be 6x minus 4 minus 6x minus 15 over 3x minus 2 square. Okay, so this and that can cancel. Minus 15 minus 4 is a minus 19. Okay, minus 19 over 3x minus 2 square. Right? Then number 28 is still a quotient. D dx of x squared minus 4 over x plus 0.5. Okay. Can we factor out anything? No. Okay. Just directly do. You copy bottom, differentiate top, minus you copy top, differentiate bottom over bottom square. Okay, then you just have to expand it. Okay, we still have 36 minutes. Okay, it is 2x squared. 0.5 times 2 is just a 1, so it's a plus x minus x squared minus 4 over x plus 0.5 squared. Okay, then 2 minus 1 is, okay, 2 minus 1 is just 1 x squared plus x minus 4 over x plus 0.5 squared. Okay, number 29, d dx of 1 minus x, 1 plus x squared negative 1. Okay, this actually, you can actually use a product rule and a chain rule here, but for now, since we are doing all the quotient rule, let's just use the quotient rule. Okay, so I'll write one more step for you. This is 1 minus x over 1 plus x squared. Okay, so it should be, we copy bottom, differentiate top, minus copy top, okay, top, differentiate bottom over bottom square. Okay, so it is negative 1 minus x squared minus 2x, minus become a plus 2x squared over 1 plus x squared. Okay, then 2 minus 1 is 1. Okay, x squared minus 2x minus 1 over 1 plus x squared. Okay, number 30. Okay, 35 minutes. We are doing good. Like, I think maybe we can hit 60 or 1 minute per question. I'm not sure about it because we have like all the chain rule and implicit differentiation. I think we have somewhere the implicit differentiation somewhere in this question. Okay, anyway, d dx of. Oh, by the way, I think I saw Blackpenredpen did a differentiation shortcut video, like 2 to 3 minutes, all the shortcut with like the fraction, the square root. I think you guys can go and watch it. Yeah. And where were we? Okay. So this should be, again, is a quotient rule. So you copy bottom, okay, copy bottom, square root x plus 1, then you differentiate top. Okay, by the way, did I mention it? When we differentiate square root x, it is just 1 over 2 square root x, because this is actually d dx of x to the half. So you bring down the power, it should be a half x, then half minus 1 is a negative half. So this is actually 1 over 2, because it's negative, then you just bring down it. Okay, so it's a 1 over 2 square root x. Okay, so yeah, this is where we can use this shortcut here. Okay, you differentiate the numerator. Okay, so it is 1 over 2 square root x minus 1 becomes a 0, right? Then minus, you copy top, differentiate bottom. Again, this 1 over 2 square root x. See, this is very useful, right? You can just use this shortcut in your exam. Then bottom square. Okay. Okay. For this question, let me clear some space here. Okay. As you can see, we have 1 over 2 square root x for both of them. So we can just like multiply with 2 over square root x like this, so that we can cancel, and this one we just put at the bottom to make our life easier, so that we don't have to go through all the trouble. Okay. Then this should be a square root x minus x, because nothing. 1 minus 1 is a 1 plus 1, which is 2 over. Then remember we have a 2 square root x plus 1 squared. Okay, then these 2 and 2 can cancel. It's a 1 over square root x plus 1 squared. Okay, this is a 1. Right? Then number 31. Clear this one. Number 31. Okay. d dx x minus 4 square root x. Oh, sorry, this is just a normal x. It's a 1 plus x minus 4 times square root x over x. Okay, again, you can just simplify it. I don't want to do a quotient rule for this one. Okay, I just do whatever you like. Math is like this. It's like you have tons of methods, you have many solutions, but you can usually you only have one answer. But you can have different approach, different method. Okay, then plus with 1 minus 4 square root x over x. Okay, 4 square root x over x, this is actually x to the half, then times x to the negative 1. So it's a x half minus 1. So again, this x to the negative half. Okay, so d dx of 1 over x plus 1 minus 4x negative half. Okay, then this one you can just directly differentiate. Change the sign, power, and power plus 1, plus this is 0. Then minus become a plus. 4 times half is a 2. Okay, so that's 2 x negative. This one minus 1 is a 3 over 2. Okay, then number 32. Okay. d dx of 1 over x squared minus 1 x squared plus x plus 1. Okay, so we cannot just split like this. We need to use the quotient rule. Okay, so you copy bottom x squared minus 1. Oh, perhaps maybe we should expand it first. Okay, so it's a d dx of 1 over x to the 4th plus x cubed plus x squared minus x squared plus x plus 1. This is a minus, sorry. Both of them should be minus. Okay, minus. Then you group all the like terms. 1 over this and that can cancel. It's a x to the 4th plus x cubed minus x minus 1. Okay, wait, let me check my camera. Okay, we still have some battery. It's good. Okay, 32. Then we continue here, yeah. So we have half an hour left. Where are we? Okay, you copy bottom. Okay, copy bottom. X4. I'm not covering the one. X cubed minus x minus 1. The differentiate top. This is actually just 0. So yeah, I want to save some space, so I just erase this part. Yeah, sorry. Yeah. Then minus you copy top. Then you differentiate bottom. So it's a 4x cubed plus 3x squared minus 1. Am I covering any? Am I? Then bottom, bottom x4 plus x cubed minus x minus 1 squared. Okay, so yeah, you can just expand the terms inside. This is the 32. So you just expand inside this negative, you just give it to all the terms inside. Okay, so it's a negative 4x cubed minus 3x squared plus 1 over x to the 4th plus x cubed minus x minus 1 squared. Alright, number 33. Okay, 28 minutes. Dx of x cubed. Why so many quotient rule? Oh my god, it's like all the quotient rule. But anyway, copy bottom, differentiate top, b0 minus copy top, differentiate bottom over x squared. Okay, so this will be a 3x to the 3rd power, then minus x cubed minus 7 over x squared. Then this and that is actually just a 2x cubed. Okay, sorry, I want to save as much. Wait, right? No, this is a negative. Okay, 33. Damn, any mistake? Wait, let's redo this question. I'm so sorry. Did I copy a question wrongly? No. Okay, so we'll use. Wait, why don't we just simplify it? Because you can see here, we only have one term at the bottom, so we can just what, you know what? We just simplify it. So it's a x squared plus 7 over x. So it should be a 2x to the 1st power. Change the sign. 7 times 1 over x squared. So it's a 2x minus 7 over x squared. Just like that. Okay, you don't have to go through all the trouble. Use all the quotient rule answers. Okay? Like I think in your exam, just try to avoid all the complicated product rule, quotient rule, chain rule as much as possible. Just do this. This is the easiest step to avoid mistake. Okay. Okay. Then number 34. Okay. dx of x minus 1 x squared plus x plus 1 over x cubed. Okay. Then yeah, so again you can expand this, then simplify with the x cubed on the bottom. Okay. Then it's a dx of x cubed minus x squared plus x minus x squared minus x minus 1 over x cubed. Okay. Then we just group all the like terms. Okay, dx of x cubed. This and that will be a negative 2x squared. This and that can cancel, minus 1 over x cubed. Okay, so it's a 1. Sorry, we still have the dx of 1 minus 2 over x minus 1 over x cubed. Okay, so when you want to differentiate this will be a negative. Then change the sign. Power 2 times 1 is still 2 over x squared. Then change the sign. All power, new power. Right? This is number 34. Okay? 35. dx of 1 plus 3x over 3x, 3 minus x. Okay. We have a quotient here and a product here, but yeah, why don't we just expand the terms on top first? Okay, just make our life easier. Okay, dx. Okay, we still have like 24 minutes. Okay, 1 plus 3x, 3 minus x over 3x. Okay, then it should be a dx of 3 minus x plus 9x minus 3x squared over 3x. Okay, yeah. See, it's so much easier that we can just cancel out the terms like this. It's a 1 over x minus 1 over 3 plus, it should be a 3. Then this is this and this can cancel, this and this can cancel, it can be negative x. They can make any mistake. Yeah, if I make any mistake throughout this video, please comment down below and let me know, okay? Because yeah, this is like a speed run, like a marathon. And anyway, it's like a more chill derivative marathon. Okay, you change the sign, old power, new power. This is you just know this shit. Then negative 1. Then 36. And finally, we don't have any more quotient. I'm not sure if we have it later when we do the triangle and exponential question. But I doubt if we can reach that. I think if we can reach question number 50, it should be good enough already. Okay. Number 36, we have dx of 3x minus 1, 4. Yeah, this is where we use the chain rule. So again, I will show you one detail working, and for the rest, we'll just use the shortcut way. Alright? So we let u equals to we let y equals to u to the 4th power, where u is the inside function. Okay? So this is what we call an inside function, outside function. Right? So dy du is 4u to the 3rd power, du dx is the 3. Okay? So what should you do? Dy dx will be dy du times du dx. The logic is here because du and du can cancel. Simple, right? And actually, if you want to prove the chain rule it's quite complicated to prove the chain rule. And I think I proved it in my very first video of this channel. Yeah, I started my channel with all the derivative proof. So this is why I decided to end this year with like this 1 hour derivative challenge. I think it's quite meaningful, right? Okay, anyway, this should be this times this. So it's a 4u cubed times 3 is a 12u cubed. So, and remember to unsub your u. So it's a 12, where's the u? 3x minus 1 cubed. Okay. This channel is inspired by Blackpenredpen. Yeah, so that's why I'm using Blackpenredpen. Okay, dx of 3 minus 2x 7. Okay, again, you can just bring down the power 2x, then this should be a 6. Then what should you do next? This is not the end, yeah? You need to multiply with the derivative of the inside function. So let me write down for you. dx of 3 minus 2x. So it's a 7, 3 minus 2x, which is 6 times negative times negative 2. Maybe I should use a red color. Okay, negative 2. Okay, so it's a negative 14, 3 minus 2x, 6. Alright, number 38. Okay, dx of 4x squared plus 7, 9. Bring down the power. Okay, 4x squared plus 7. 9 minus 1 is 8. Then you multiply with the derivative of inside function, which is and add x. Okay, 9 times 8 is 72. Am I right? Yeah. 4x squared plus 7. Right. Sorry, we have an x here. Okay, so this is number 38. Okay, 20 minutes. Oh my god, can we reach question 50? We just try to reach number 50, okay? 39 dx of 2x plus 1 the 5th power. Bring down power minus 1 inside function. Okay, so it's a 10 2x plus 1 to the 4th power. Okay, 40. Okay, d 1 minus minus x over 7, negative 7, bring down power, 1 minus x over 7, power minus 1, times with a derivative of inside, which is 1 over 7. This and that can cancel, so it's 1 over 7, negative 8. Okay? Okay, 40. Let me check the battery. Number 41. Okay. D dx of 3 over 2x plus 1. Again, we need to use the quotient rule because we can't split into two fractions. Oh, wait. Oh, we can actually use chain rule for this, you know. Okay, so let me show you. Okay, we let y equals to maybe 3 over u, then u equals to 3x plus 1, right? Then dy, okay, then dy, du will just be negative 3 over u squared, and du dx will just be 3. Yeah, then we can just like cancel better. Okay, so dy dx will be negative 3 over u squared times 3, which is a negative 9 over u squared. Remember to unsum your u is 3x plus 1 squared. Okay, so this number, do we make any mistake? No, 2x. This should be a 2x. Okay, 2x. This is a 2. This is a 2. This is a 6. Okay, sorry about that. Okay, 41, 42. It's quite fun. I'm really tired. That's why I don't think I can do like 6 hours straight of differentiation. Okay, just 1 hour it should be nice. Yeah, then 6 over x minus 5. But if I'm still running my YouTube channel, maybe I will do it in the future. Anyway, again, we can just use the chain rule like that. We let y equals to 6 over u, then u equals to x minus 5 to the 4th power. So dy du will be negative 6 over u squared. Then du dx is 4x minus 5 times 1, okay, which is just like this. Okay, times 1, okay, which is 4x minus 20. Okay, minus 20. Then where will we? Okay, dy dx will be this times this, negative 6 over u squared times 4x minus 20. Okay, so it is just leave a negative outside. 24x minus 120 over u squared. Where is our u? Okay, x minus 5, 4, then u squared again. So it's negative 24x plus 120 over x minus 5 to the 4th power. Are we doing it? Is it? Why is the number so big? Sorry, we have a cube here. So sorry, my mistake. 4x minus 5 cube. So this should be oh my god, I'm running out of time and I'm doing all the mistake. I'm so sorry about it. Times with 4 times x minus 5 cube. But for those who are watching math channel, don't you just want to see how we screwed up? Isn't it? Yeah. So it is a negative 6 times 4 is 24 x minus 5 cube over u squared. Okay, I just directly write like this. 4th then squared. So this is actually to the 8th power. Okay, this is just to the 8th power. Then this and that will just becomes a 5, so it's a negative 24 over x minus 5 to the 5th power. Okay? Number 43. Oh my god. Okay, d dx of x squared over 8 plus x minus 1 over x to the 4th power. Okay, you bring down the power, x squared over 8 plus x minus 1 over x cube, then you differentiate inside. Okay, inside function should be a 2. Okay, it should be a 2 over 8 is just 1 over 4, so it's a x over 4 plus x over 4 plus 1 plus 1 over x squared. Okay, So I think for number 33, I will just leave it like this, okay? For default, okay, d dx of square root 3 minus x. So again, this is a chain rule, and I told you that this is just 1 over 2 square root 3 minus x. Then you differentiate inside. Differentiate inside, which means it's this part here. So it's a negative 1. Okay, so it's a negative 1 over 2 square root 3 minus x. Okay, number 45. Okay, 40 minutes. Okay, 45, I do it here. D dx, oh my god, 1 over 18, 3x minus 6, minus 2. Okay, minus 2, 6 plus 4 minus 1 over 2x squared, negative 1. Okay, this is just a sum rule. So 6 over 18, 3x minus 2, 5, then this is a 3, and this actually, this and this can cancel. Minus, minus 1, 4 minus 1 over 2x squared, then this is minus 2, multiply with positive 2 over 2x cubed. Okay, this and that can cancel. So at the end, you have 3x minus 2 fifth minus x cubed, minus 1 over x cubed, minus 1 over x cubed, then this is the on the bottom right, minus 1 over 2x squared. Okay, number 46. Okay, I think, okay, I just target 50 questions, okay, just 50 should be nice. 46. Okay, d dx of 4x plus 3, 4x plus 1 negative 3. Okay, oh my god, this is a product rule plus chain rule. Okay, so you copy first function, differentiate second function, x plus 1 negative 4, then times with inside function which is 1, then plus with you copy second function, then you differentiate the first function for x plus 3, 4. Okay. Then yeah, I think I will just write like this. 4x plus 3 to the 4th, x plus 1 negative 4, plus 4 times 4 is 16. Okay. This is a cube, yeah. 4x plus 3 cube, x plus 1 negative 3. I hope I don't make any mistake here. Anyway, 47. Okay, last 11 minutes. 3x, 2x squared minus 5, 4. Okay, it's a product rule plus chain rule. Okay, so you copy first function, differentiate second function, square minus 5 cube 4x. Okay, then you copy second plus with a second function, differentiate first function. Okay, and this should be a 3 times 4 times 4, 12 times 4 is 48. Okay, 48 x 2x squared minus 5 cube. Yeah, this one already, yeah. Then plus with a 3 times 2x squared minus 5 to the 4th power. Yeah. Then next question number 48. Okay, 48. We have, oh my god. Okay, this is a very complicated chain rule. But anyway, this is actually sorry for my bad writing. Okay, 3x plus 2 plus minus x. Come on, I want to finish this by this year. Okay, so like I said, you can just use 1 over 2, then the square root of all the inside stuff, plus square root 2 plus 1 minus x. Then you just differentiate this part. Okay, then you just times with the derivative of this part, which is 3 plus, this should be a 1 over 2 times 2 plus square root 1 minus x again. Okay, then this one again, you need to multiply with the derivative of this part. Okay, so it's a 0. Okay, 0 plus 1 over 2 square root 1 minus x again. Okay, then you just have to simplify this. And I don't think I am combining two of them. I just leave this outside. Okay, 2 3x plus square root 2 plus square root 1 minus x. Okay, times 3 plus 1 over 2 times 2 is 4. 2 plus square root 1 minus x. Then we still have another 1 minus x. I think I will just leave my answer like this. Okay, anyway. Okay, last 9 minutes, 49. Oh, we finally have implicit differentiation. Okay, y squared equals to x. Okay, so what we'll do here is that we differentiate both sides with respect to x. Okay, of y squared equals to d dx of x. And if we are doing implicit differentiation, actually, as you can see here, we are assuming that y is a function of x. So actually, we are using chain rule. Okay, so okay, let me show you. Okay, so by chain rule, you just differentiate outside function, then times the derivative of inside function, isn't it? So okay, so if this is an outside function, you just put 2y, then y minus 1, right? Then what is the derivative of inside function? It's a d dx of y. Because we don't know what is inside y, right? So we just write like this. Then this will just be a y. Okay, right over here. So it's a 2y. What is d dx of y? It's just dy dx equals to 1. So dy dx will be equals to 1 over 2y. And that's the answer. Okay. So by the way, actually I think in October I did a video on the shortcut of implicit differentiation. We can just arrange this. Okay, so it's a y squared equals to x, right? So we just arrange it equals to 0. Then dy dx will just be negative. It's a quotient. Okay. Okay, so the one on top is a partial derivative of this of your left hand side, which means you take y squared as a constant, so it will just be a negative 1. Then on the bottom is a partial derivative. It's a partial derivative with respect to y. So it's a 2y. This is a constant now, minus 0. So it is a 1 over 2y. Okay, so if you are interested, you can just go and watch my video. Okay, number 50. Okay, it's x squared over y equals to 0. It's another implicit differentiation. Okay, so this will be you copy bottom, differentiate top, minus you copy top, differentiate bottom, you will have a dy dx over a bottom square. Okay, then we want dy or dx, so we just multiply both sides by y squared. This will just be 0. So dy dx will be, this will be a 2xy, we have a negative here, over negative x squared. This and that cancel, this cancel, negative 2y over x. Okay, let's do some TRIG. Okay, let's try to hit 60 now. Okay, so that we have 60 differentiation, 60 derivative in 60 minutes. Okay, the last 60 minutes, the last 60 derivative of the year. Okay, so this will be a 2x minus the derivative of sin x is cos x. Okay, 52. We have d dx of x squared sin x. Okay, so it's a product rule. Copy first function, differentiate second, plus copy second function, differentiate second function. Okay, 53 d dx of sin x. Okay, it's a quotient rule. Okay, copy bottom, differentiate top, minus copy top, differentiate bottom over bottom square. Okay, 54. Yeah, I think we can hit 60 like this. Okay, 5x plus cos x, then 5, then okay, the derivative of cos x is negative sin x. Okay, 55. d dx of sin x cos x. Okay, this is another product rule. Copy first function, differentiate second, this is a negative x, negative sin x, then plus with copy second function, then differentiate first function. Okay, this first differentiate first function, you get a cos x. Okay, so it's a negative sin square x plus cos square x, and this is actually your double angle for cos, isn't it? So it's a cos 2x. Okay. don't worry, we can finish, we can do this in time. Then I hope I can finish this in time to wish you a happy new year. Okay, so d dx of cos x 1 minus sin x. Okay, is a quotient rule. Copy bottom, differentiate top. Okay, then you copy top. Okay, copy top, differentiate bottom. It's a negative cos x. Okay, then over a bottom square. Okay, so it's a negative sin x plus sin square x minus become plus cos square x over 1 minus sin x squared. Okay, and this part here is actually identity is equals to 1. Okay, 1 minus sin x, and this is actually the same, so it's a 1 minus 1 over 1 minus sin x. Okay, number 57, d dx of negative 10x plus 3 cos x. Okay, it's actually a constant multiple here, but don't worry, it's the same. They are all the same. Negative 10 minus, yeah, for cos you differentiate, take a minus. Okay, so negative 3 sin x. Okay. Almost done. Okay, this is x. Okay. d dx of x squared cos x. Okay, so this is a product rule. Copy first, then this is a negative differentiate second, plus copy second, differentiate first. Okay, then you rearrange it. Sin x plus 2x cos x. Okay, 59. Okay, we are almost done. And perhaps maybe for the last question, why don't we do a first principle? Yeah, I will pick just a easy question. Okay, so this is a cosecant x. Cosecant x will get a negative cosecant x cotangent x. I have proved this in my second video. Okay, then again this will be a 4 over 2 square root x plus 7, you get a 0. Okay, negative cosecant x cotangent x minus 2 over square root x. Okay, so for question 60, why don't we try first principle? Okay, let's end this year like with a first principle of derivative. Okay, so maybe we pick a easy question. Okay, we pick from question number 1. Okay, we do question number 1 again. Okay, but this time we try to do it using first principle. Okay, so by definition, this will be the limit when h approach 0 of f x plus h, right? X plus h minus fx over h, right? So it will be a limit when h approach 0 of x plus h raised to the 4th power. It's a binomial expansion. Never mind over h. Okay, it's a binomial expansion to the 4th power, so it should be a, okay, don't worry, limit when h approach 0 x to the 4th power, then should be plus 4, then 6, 4. Okay, x cubed h plus x squared h squared plus 4x h cubed, right? Then minus plus h cubed. Yeah, so this is a binomial expansion. Then don't forget the minus x to the 4th power over a h. Okay, then what's next? Okay, so this and this can cancel. Then we can factor out all the h. Okay, then limit when h approach 0. This h cancel. So it's 4x cubed plus 6x. Oh, sorry, this is a h squared. This is a h squared. So we only cancel out one h. Then plus 4x. This is a h squared. Okay, this is just a h squared. H cubed. So it becomes a h squared. Okay, h squared. Right, so I use red color for h. Then nothing else. Oh, sorry. This is h cubed. So it becomes h squared. Okay, so plus with a h squared. Then now we sub in 0 for all the h. So this will be 0, 0, 0. So the answer will be 4x cubed, and that's the answer. Okay, we still have like last minute. So thank you everyone for the support throughout the year, and I hope you guys enjoy my math. Let's do more math for fun, and Happy New Year!